Hello, it's Andy here, and welcome to episode 6 of my Sans 2018 Holiday Hack Walkthrough. Things were looking pretty rough at the end of the last episode, with Hans and the toy soldiers taking everyone at KringleCon hostage, unless the villains who tried to destroy Christmas in the previous holiday hacks were released. Hopefully we can find out more by solving our next objective. As always, let's start by lending a hand to one of Santa's elves in case we need their help. Here we find Holly Evergreen, who's having problems with the candy cane striper. It's stopped working and can only be restarted with a call to a specific URL. Let's start by calling curl to send a basic HTTP request and see what comes back. This seems to just be junk, which is rather odd as it should at least return some sort of legible headers before any data. We're told we can take a look at the web server configuration file Nginx.conf. In here, we can see that this web server is configured to use HTTP version 2. Before the toy soldiers started acting up, I managed to catch a talk by Chris Elgie about HTTP 2, in which he said that HTTP 2 sends headers in a binary rather than a human-readable text format. So that's probably what the junk data was that we just saw. Okay, so let's go back to curl and provide the HTTP2 flag to tell it to expect a HTTP2 response. But we get the same result. Another browse through the web server config file shows gzip enabled, which will compress responses from the server so that they're smaller. Perhaps the junk data we're seeing from the web server is gzip data. Curl should handle this automatically without us needing to do anything, but it's quick and easy to test this hypothesis, so let's give it a try. We just need to send the output of curl to a file, and then run the gunzip command on that file. But no, this data is not in gzip format. A quick poke around the system to look for any more clues shows no particular files of interest in the user's home directory, but the command history has a good lead. Here we see all of our commands, but there's a bunch of stuff beforehand, including the curl command, which uses the HTTP2 prior knowledge parameter. Now everything slips into place. A little bit of googling about the HTTP2 protocol specification and a check of curl's help page shows us that whilst the HTTP2 flag turns on HTTP2 communication, it does this by upgrading the connections from 1 to 2 over HTTP1. But our Nginx server is configured to talk only HTTP2, hence always returning binary data. So we need to use the prior knowledge option to tell curl to just talk HTTP2 off the bat. After all, we already know this server talks HTTP2, so there's no need to discover this via an HTTP1 conversation. And sure enough, we're now getting some sensible data returned. This page tells us we need to send a post HTTPS request with the parameter status equals on. We can get curl to do this for us with the -d option. And there we go. The candy cane striper is back up and running, so we can get back to the main objective. We're tasked with examining the contents of a virtual machine and finding a Kerberoastable user whose compromise could lead to domain admin access. After booting the image, we find ourselves in Slingshot Linux, with a link to Bloodhound sitting on the desktop. Bloodhound is a query and visualization tool which can be used by attackers and defenders alike to understand the relationships between entities in an Active Directory environment. It can quickly and easily highlight opportunities for lateral movement and privilege escalation, which would otherwise be hugely difficult and time-consuming to spot. It does this by combining an inbuilt awareness of the common tactics used by attackers to compromise Windows environments with a dataset captured from a live AD environment. We are tasked with identifying the name of a Kerberoastable user account, which provides the shortest lateral movement path to achieving domain administrator privileges. I shan't dig deep into the technical details here, but Kerberoasting is a technique which can be used in certain situations where user accounts are assigned Kerberos Service Principal names, or SPNs for short, to crack account passwords. It's quite a powerful attack, as the information required to perform it can be extracted by any attacker who has obtained unprivileged access to a domain, and the process does not risk creating a large number of failed login events in logs, so can be difficult to spot. The dataset for a live AD environment includes any service principal names associated with accounts, meaning Bloodhound can easily identify which are potentially vulnerable to Kerberoasting. And with its knowledge of the rest of the Active Directory environment, it can plot possible routes to achieving domain administrator privileges. In fact, one of the predefined queries that comes packaged with Bloodhound does exactly that, producing a visualization of the possible options in just a few clicks. Here in green we see several user accounts that are vulnerable to Kerberoasting, and on the right is the domain administrators group. Let's follow each branch to examine the possible chain of attacks which lead from each Kerberoastable user to domain admin. The first two Kerberoastable users, Rosie Hadel and Jay Fox, are members of the IT256 group. Members of this group have permissions to establish a remote desktop session to computer 450. Another individual who had a session on this machine is Gordon Leopatcher, meaning any individual who is able to gain administrator level access to computer 450 might be able to extract a valid security token for Gordon's account and impersonate him. Gordon in turn has permission to RDP into computer 284, which also has a session for Zenaida Andrea, who is a member of the domain administrators group. Scarlet Marcella has execute decom rights onto computer 50. The help information for this relationship even gives us some PowerShell code as an example exploit. Maud Teta also has a session on computer 50, so could be at risk of being impersonated by someone who has administrator level access to that machine. Maud is also a member of the IT256 group, so an attack could continue down the same path as described previously. Randall Weffenholtz can RDP to computer 300, where Jane Gumbel has a session, who in turn is a member of the IT268 group. Leanne Dubege is a member of the IT332 group. Both these IT groups have administrator rights onto computer 185, where Jenna Betak, another domain admin, has a session. A relationship doesn't guarantee a compromise is possible, and, as we're told in the main objective, any path involving the can-RDP relationship requires identification and exploitation of an additional vulnerability. That leaves us with just a single path to domain admin from a Kerberoastable user, Leanne Dubege. We submit our answer and find out that further events have unfolded whilst we've been busy with Bloodhound. The toy soldiers continue behaving very rudely, grunting orders to the guests and to each other in vaguely Germanic phrases. Suddenly, one of the toy soldiers appears wearing a grey sweatshirt that has written on it in red pen, "Now I have a 0 day, ho ho ho." A rumour spreads amongst the elves that Alabaster has lost his badge. Several elves say, "What do you think someone could do with that?" So, Alabaster has lost his badge. Maybe that's what the toy soldiers were searching for a couple of episodes ago. Presumably whoever has it could access sensitive areas. Maybe Hans is trying to get to something that he shouldn't. I'll see you in the next episode to find out more as we work through objective number 6.